So now we'll solve some questions, and I will also give you some daily practice problem that you have to solve and come back. Let's test what we have understood. Okay. Please reply on the chat box. So this is a true or false question. Any two vectors in R2 that point in two different directions will always span R2. Not on same line. Okay. So I've modified this question correctly. It can happen that, and I also missed that I have a vector 1 in this direction, and on the same line, I have a vector pointing in a different direction, right? In that case also, it will not span because they're on the same line. Now I've added this particular value or this particular constraint here that they're not on the same line and are pointing on in two different directions. Now, that they should not be on the same line. So I've added this constraint, and then this is true, right? That these two vectors, which are pointing in two different directions and are not on the same line. So basically a vector like this, two vectors like this, or somewhere else, right? They will be able to span whole R2. Fine? Awesome. A set of two vectors in R2, which is linearly independent, will always span R2. True? True? Right? Correct. So this is also true, that I have two linearly independent vectors which are in R2. They will always span R2, right? We have seen this because we'll be able to create linear combinations which will span the whole R2. Fine. Set of two vectors where one vector is V, another vector is 0 in R2 can span whole R2.
I think one of the vector 0 can be written as 0 times of V so that it can span the whole R2.
Okay. Is it true? So a single vector, I have just V, okay. Can it span whole R2? So we have just one vector, right? So all the linear combinations of this vector will be -1 V, -2 V, -3 V, and 3 V, 4 V, and something infinity V, right? So what is this? We saw this in GeoGebra, right? This is just a line. We saw that, no? Right? So this is just a line, and we'll never be able to go in any other direction except where this V1 or this V vector is, right? So we'll not be able to span. Another way to look at it is that we have a 0 vector here, right? So we saw a question where we asked, or I highlighted that point itself, that whenever we have a 0 vector in the set of vectors, any set of vectors with 0 vector is a linearly dependent set because you can set the value 0. You can set the scalar value to be non-zero for that 0 vector, and you will get the non-trivial solution, right? So because this is 0 vector, this set becomes linearly dependent. Linearly dependent. And we saw that we need exactly n linearly independent vectors, to span Rn. And when I'm talking specifically about R2, I need two linearly independent vectors. But here I have just one vector, and this set is linearly dependent because 0 vector is present in this. Right? It's clear now, Varshita?
Yes, ma'am.
Right? Raidu, clear to you as well? Clear. Fine. So this is false. This will not be able to span the whole R2. Linearly polarized. I don't know what that term means. I will check and get back, but I'm not aware what is linearly polarized. Straight line. Yeah, basically all the vector or all the combinations that I take from this set will be a line. Fine. Fine. Can any set of three vectors span R3, whole R3? False, right? So any set cannot span. So this is false, because for any set, what I can do is I'll take two vectors where A and B are coming from A, B are coming from R3, and I'll take a zero vector, right? This is one of the sets, right? So this is linearly dependent set because zero is present in this, and hence will not span R3. Linearly dependent. Yeah, only will not span R3. What are you guys saying? That linearly independent only. Only three linearly independent. Right. Yeah. So correct answer is, so you are forward than me. So correct answer would have been, only three linearly independent vectors from R3 can span R3, right? So this is false. I have already written this. This is false, right? You have to check whether this set is a linearly independent set or not. We'll discuss this question tomorrow, and where X is coming from Rn. Fine. So this is your problem for, you have to check this. Okay. This is a DPP, your daily practice problem. Fine. Please solve this at home and we'll discuss this tomorrow. So what we have learned today. So we wanted to know more about vectors. We learned about the linear combination of the vectors. We also learn about span of a set of vector. And also we learn what is linear dependence and linear independence in terms of a set of vectors.